Chapter 3, Section 3, Zeros of Polynomial Functions. In question number 11, we're asked to list all the possible rational zeros and find all rational zeros and factor f of x. The way you list all the possible rational zeros, called the rational root theorem, all rational zeros are in the form of a fraction, or can be written as a fraction, where the numerator is a factor of the last term divided by the denominator, which is a factor of the leading coefficient. Now the last term here is our negative 12. The leading coefficient is 6. So in the numerator, we're going to list all of the factors of 12. Factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. The factors of the leading coefficient 6, that would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So all of the rational zeros can be written as any of these numerators divided by any of the denominators. So we can generate a list of possibilities. If we do 1 over 1 as a possible zero, plus or minus 1 over 1, plus or minus 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. And then we could take all of these things in the numerator and divide them by 2, which is 1 over 2, 2 over 2, 3 over 2, 4 over 2, 6 over 2, and 12 over 2. And then we can divide all of these by 3 to get even more, which is 1 over 3, 2 over 3, 3 over 3, 4 over 3, 6 over 3, and 12 over 3. And then divide all of these by 6 to get 1 over 6, 2 over 6, 3 over 6, 4 over 6, 6 over 6, and 12 over 6. Now we have, this is our big listing, but this can be reduced. We're going to reduce them so that we can generate the entire list. If we take all these divided by 1, it's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now I'm not listing out the plus or minus, but that's understood. And then divide all these by half. We get 1 half. Now the 2 over 2, this simplifies to just 1. We don't need to list it again. Then we have 3 over 2, 4 over 2. This simplifies to 2. So again, we don't need to simplify it. We don't need to list that. This is 3. This is 6. And we already have those numbers. We're going to divide all these by 3 to get 1 over 3, 2 over 3. 3 over 3 is 1. Okay, 4 over 3. 6 over 3 is 2, which we already have, and 12 over 3 is 4. Okay, I just have a couple more here. 1 over 6 is plus or minus 1 over 6. 2 over 6 is a third. We already have that. 3 over 6 is a half. 4 over 6 is 2/3. 6 over 6 is 1, and 12 over 6 is 2. So we already have that. So let me go ahead and list it like this, 1 over 6. So you can see these are all of the possible rational zeros. If it has a 0 that's a rational number, it has to be one of these, either plus or minus 1, plus or minus 2, plus or minus 3, and so on. So that in my question is choice A. We can check our answer. Now the second part of this question says to choose the rational zeros. The first part was give a list of all the possibilities, and all of the possibilities are given here. We have, excuse me. So again, the possible rational zeros are listed here. We've got quite a long list of possibilities. Now the fact that this is a third degree polynomial, that means the most that we could have is 3. We can have at most 3 rational zeros or 3 zeros. And again, out of this whole list, at most we can have 3 of them that are zeros. Now, to determine which ones are zeros, you're going to use synthetic division using the setup here. We're going to use the coefficients. Make sure you have it all coefficients listed. If there's any missing powers of x, you want to make sure you put zeros in the setup. That's not necessary here. Now what you're going to do is try synthetic division with all of these possibilities, and as soon as you get one that works, we're going to break it down to a simpler problem. Now if you try positive 1, for example, in this setup, if we end up with a remainder of 0 here, then we could say 1 is a 0 of the function. But when we go through here, bring down the first coefficient, multiply by 1, 6 times 1 is 6, negative 13 and 6 is negative 7, negative 7 times 1 is negative 7, negative 41 and negative 7 make negative 48, and negative 48 and positive 1 give you negative 48. Add these together, 12 minus 48, and that's going to be a negative 36. This does not have a remainder of 0. Okay, the remainder is not 0. So what that means is that 1 is not a 0 of the polynomial function, since we end up with something that does not have a remainder of 0. Now you would try the next one on the list. Go ahead and try negative 1. And see if you get a remainder of 0. Now I've already done this problem, so I know that you don't get a 0 remainder. So if you go ahead and try positive 2, that's not going to work. Try negative 2, that's not going to work. Go ahead and keep trying until you find one that does work, that does give you a remainder of 0. The first one that does give you a remainder of 0, if you go in that order, is positive 4. If you put a 4 in the box and use the setup for synthetic division, okay, I'm going to break down the first term, 6. 6 times 4 is 24. Negative 13 and 24 is 11. 40 times 11 is 44. Negative 41 and 44 is 3. And 3 times 4 is 12. Oh, I'm sorry. It should have been a negative 12. Okay. Either way, this should be positive 12, and that's 0. Okay, so this does give us a remainder of 0. So we can say 4 is a 0 of the polynomial function. 4 is a 0. We're going to use that information in this synthetic division to find the other zeros. Since 4 is a 0, we can factor this polynomial. With 4 being a 0, I know x minus 4 is a factor, and the other factor is found below the line with synthetic division as 6x squared plus 11x plus 3. We're going to factor the 6x squared minus 11x plus 3. Those factors. Alright, the factors of the 6x squared plus 11x plus 3, that can be factored into 3x minus 1 and 2x minus 3. Sorry, that should be a plus. plus plus. So we can double check that. 3x times 2x is 6x squared. The outer is 9x, the inner is 2x, and the last is 3. So here we have the three factors of the polynomial function. You can determine the three zeros by setting each of those factors equal to 0. If you set x minus 4 equal to 0, you get x equals 4. That's one of the zeros of the polynomial function. Set 3x plus 1 equal to 0. If you subtract 1 and divide by 3, you get negative 1/3 is a zero of the polynomial function. And then if you set the last factor, 2x plus 3 equal to 0, subtract 3 and divide by 2, you get x is equal to negative 3 over 2. Those are the three zeros of the polynomial function. We found the first one by using synthetic division to getting a remainder of 0. This allows us to factor the polynomial. Once you get it factored like this, you can use synthetic division. Another thing you could do is you could set this equal to 0 and use a quadratic formula to find the other two. Or if you use synthetic division with a negative 1/3 and negative 3/2, you would also show that you have a remainder of 0. So the solutions here are 4, negative 1/3, and negative 3 over 2. And then the last part is to choose the factors. Now I've done that in order to get the zeros of the polynomial. Factors are x minus 4, 3x plus 1, and 2x plus 3. Now I do want to show you something interesting if you have a graphing calculator, is to go ahead and graph the original polynomial function. If you turn your calculator on, press y equals, enter the polynomial equation that's given, the function 6x cubed minus 13x squared minus 41x minus 12. And put that into the y equals. And then you go to zoom. I always do a standard zoom, number 6. And you see the graph of the polynomial function. It's a third degree polynomial, so that typically indicates that the graph is going to go in three directions. It goes up, down, up. And you can see that it crosses through the x-axis in three different times. Those 3 times where it crosses through the x-axis, those are the zeros of the polynomial function. If you take a look and count over here, it looks like the graph crosses through the x-axis when x is equal to 4. You can check this by pressing trace and typing 4 and enter. You see that the graph crosses through the x-axis at 4. That's one of the zeros of the polynomial function. Get to it. I really want you to take a look at the graph, and you can tell that the graph crosses through here at 4. If you trace and type in 4, you see that's one of the zeros of the polynomial function. The other zero is negative 1/3. So if you again press trace and type in negative 1 divided by 3 and press enter, you see that's another place where the graph crosses through the x-axis. So y is equal to 0 when the x is equal to negative 1/3. And the last one, we can double check that. That is negative 3 over 2. Press trace and type in negative 3 over 2. You can see that's another place where the graph crosses through the x-axis. So negative 3 over 2 is a zero of the polynomial function.